Hi dear students, we are going to continue with the application of the second application of the determinant, finding the area of the triangle. Of course it should be in coordinate plane, and the area of the triangle with vertices x1, y1, x2, y2, x3, y3 here. It's going to be like here, we are going to define 3 points. When we connect them, we may get one triangle. And in the area of triangle we are going to use by using this formula, which is equal to 1 over 2 times here plus minus 1 over 2 times x1 y1 1 x2 y2 1 x3 y3 1. It's going to be where the plus minus sign we are using, because the area it has to be positive. If the result of determinant come up minus, then it means that you're going to use here minus 1 over 2, and you should make the area positive, because here you remember from the previous properties, if you switch the places of x1 and y1, x2 and y2, you will get the negative one, which means the order is not important, only the area value, it should be positive for us. Now we are going to continue with the exercise, and here the coordinates are minus 3, 5, x1 and y1. This is x2 and y2, and we can count this one as x3, y3. As I mentioned before, the places are not important. You can see this is x3, y3, and this is x2, y2. Only the formula you shouldn't forget, plus and minus sign here is equal to 1 over 2 times. I'm going to write the determinant now. Here minus 3, 5 and 1, 2, 6 and 1, and then here it's going to be 3 minus 20 and 1 it has to be. So if I do row operations here, I'm going to do the row operations, and I'm going to fix this problem, like here this is going to be 0, this is going to be 0, then I'm going to do ISO operation. And the row operations doesn't change the determinant value, we remember that one. So minus R2 plus R1 plus R2, it should be equal to new R2. And minus R1 plus R3, it should be equal to new R3. So by using these operations, I'm going to get easier determinant. And here I'm going to keep plus and minus 1 over 2. This was from the formula, and I'm going to do row operations on the determinant part. Minus 3, 5 and 1, these are going to be fixed, because R1, the first row, we are not changing, but we are going to make this one 0 and this one 0, and then I'm going to use column determinant, which is here minus and minus 3 plus 2, that makes 5. Minus 5 plus 6, it is equal to 1. Minus 1 plus 1 is equal to 0. Minus and minus 3, here it's going to be equal to 6. Minus 3 plus 3, it's equal to 6. Minus 25, it's going to be equal to minus 5 minus 20, it's going to be equal to minus 25. And minus 1 plus 1, it's going to be equal to 0, it should be. So I got one column 0, 0, 2 entries 0, 0. Then I'm going to apply the cofactor expansion here, plus and minus 1 over 2 times. Let me open parenthesis. Here cofactor expansion says that here I'm going to use cofactor expansion for this row. I'm sorry, for this column. And here it's going to be the entries, leading entries 1 times minus 1 to the power of, this is third row, third column, 3 plus 3, then times the minors are 5, 1, 6 and minus 25, it's going to be 25, it is, then plus 0 times minus 1 to the power of something, it's going to be here, it's second row, third column, which is 2 plus 3, times something it's going to be, but this is completely 0, and that's why I made the row operations, by the way. And the plus, then 0 times minus 1 to the power of, this is third row, third column, it's going to be, then it's going to be equal to, this is first row, third column, it was Okay, and here 3 plus 3, this part also it's going to be equal to 0, so I'm going to close the parenthesis like this, which is equal to plus and minus 1 over 2. Here it's going to be 4, the total is 4, so minus 1 to the power of 4 times 1, it's equal to 1 times, in parenthesis I'm getting now, again parenthesis, minus 5 times 25 is equal to minus 125. 6 times 1 is equal to minus 6, and it's going to be equal to here minus 1 minus 6, then plus 0 plus 0 it's going to be, but as I said before, we are not going to count them, so it's equal to plus and minus 1 over 2 times here 1 times minus 131, which is equal to minus 131 it's going to be. So the area formula, we are finishing now, area is going to be equal to 1 over 2 times 131. We are using the negative form to make the operation positive, so which is equal to 131 over 2 it has to be, and you may leave as a fraction the answer. If we have another question here, like minus 2, 4, 1, 5, 3, and minus 2, I'm going to quickly solve again the area by using the row operations. Plus and minus 1, pardon, minus 2, 4, 1, 1, 5, and 1, 3, minus 2, and 1 it has to be. Here, as I mentioned before, I'm going to use the row operation. I forget the minus 1 over 2. Minus R1 plus R2 is going to be new R2. And minus R1 plus R3, new R3, it's going to be for us. And let's see how the row operations is going to change the determinant. I mean, the value is not going to change, but the entries are going to change. Here minus 2, 4, and 1, these are same, and minus 2 plus 1, it's going to be equal to 3, minus 4 plus 5, it's going to be equal to 1, minus 1 plus 1, it's going to be equal to 0, minus 2 plus 3, it's equal to 5, minus 4 minus 2, it's going to be equal to minus 6, minus 1 plus 1, it's going to be equal to 0 for this one. Again, as I mentioned, I'm going to do column operation. For the columns, I'm going to, column I'm going to use for the cofactor expansion. Here, this column I'm going to use, and again, I'm going to continue with the same method, minus 1 over 2 times, bigger parenthesis. Here, the 1 times minus 1 to the power of, this is third row, third column. I'm sorry, this is first row, third column. Again, I made the same mistake. First row, third column, and times here the minor, it's going to be equal to 3, 1, 5, and minus 6. Then plus the entry is 0 times something, it's going to be plus 0 times something, it's going to be, but these are not important for us because the result is going to be equal to 0. Here this is minus 1 times here, as you see, to the power of 4, minus 1 to the power of 4, 1 times 1, it's going to be equal to 1, which is equal to 1 minus 1 over 2 minus plus 1 over 2 times here 1 times in parentheses 3 times minus 6 is equal to minus 18, minus 5 times 1, it's equal to minus 5, which is equal to minus 23 it has to be. So the answer is minus 1 over 2 times minus 23, which is equal to 23 over 2 it has to be. This is the second area of the triangle.